model-based evaluation of factory layout variants. Yeah, thank you. My name is Thomas. I'm from the Fraunhofer IGCV in Germany. My background is production engineering, so I'm a bit exotic here. But first of all, I have to thank you, Robert Amor, for hosting me in New Zealand and being such a wonderful host in New Zealand, where this paper was created due to my stay abroad. Okay, let's give me first a short introduction in factory planning. What is a factory? A factory is a place where products are produced or where values are created. On the right-hand side, you can see also a short video how just a factory looks like. And what you can see, a factory consists on the highest level of a production system and a building system. And to be honest, for us factory planners, the building is just there to protect our production system from the environment, from the rain and all this stuff. But yeah, we are gaining or we are earning money with the production of several goods. And to plan factory is a systematic and object-oriented process which is structured into several phases or several sequences. And one of these phases is the factory layout planning, which is here the last definition. And in the factory layout planning phase, the individual facilities, the equipments, the robots, all the logistic elements, what you can see in this video, are just spatially arranged into the building. And this is also the first phase or the first step in the factory layout planning process where the production system meets the building system. And therefore it's a very crucial step because you can generate a lot of variance. You are really free, or you are still really free, but you can influence the costs of the later factory a lot in this step. And yes, as I said, in this first step, you're generating variance. You have to evaluate these variance for the later on detailed planning. And how we do this normally. So in factory planning projects, we have normally factory objectives, like here you can see ecological sustainability, changeability, or economic efficiency. But these are very general objectives, or they are kind of unconcrete. If you go a level deeper, then you can see that you have different evaluation criteria, like space utilization rate, or the length of the pipe network, or minimum floor load bearing capacity, and all this stuff, or material flow costs, which can be used to operationalize these factory objectives. And in a traditional or in a conventional way, you are just using value benefit analysis. So you're having your evaluation criteria, you are weighting these individual criteria, so the sum is 1, and then you are just analyzing your variance and giving them a certain value from maybe from 1 to 10, from very bad to very good. And then you say, okay, variant 1 is superior to variant 2. But this is a really objective approach, and it's really up to the experience of the factory planner or which person is doing this evaluation. So our research question was, how can the evaluation of factory layout variance can be performed more efficiently to enable fast and reliable decision making, as we see that, especially in factory planning projects, we are planning more model-based and not so much in 2D or just with drawings. So it's coming more and more that we are planning model-based. And what we are discussing in New Zealand, or what we discussed in New Zealand, was how we can use tools existing there. And we decided for one tool, which is called ACABIM, Automated Compliance Audit of Building Information Models. This is an open standard digital platform which is normally made for rule checking, but yeah, it is quite flexible because you can just input a lot of data like models, direct input, lists, and all the stuff. You can process or you can operate different calculations just via giving certain operations via BPMN, and then you have the calculation engine, and then you get out the report out of that. And this is what we try to use for or to evaluate factory layout variants. And in the use case where we used it, we just started with a really, really basic factory layout variant. So this is just the ideal layout variant where this has nothing to do with the building or something like this. It's just about the material flow, how it would be perfect. So the material flows from the left screen to the right screen box, and just with a direct flow over this red and this orange boxes, what you can see there. So this is really direct, a really linear flow. And if we are bringing this ideal layout into different buildings, we have here two different variants, factory layout variant 1 and factory layout variant 2. Then you can see that we have to adjust these layout variants a bit to the constraints of the building or to the structure of the building, what we actually having over there. So what you can directly recognize is that the material flow is more formed like an L in the lower variant, or this is wrong. This should be factory layout variant 2. It's more like an L, and in the upper variant, it's more like a straight layout where you have a straight material flow. So what we've done is we've just given all this information, all these different models of our factories, of our factory layout variants, all these lists like transport matrices and all this stuff into our ecological system. And then we performed some tasks, which you can see here, or we performed some processes, which you can see here, to just automate it or automate the calculation of these different factory objectives or these evaluation criteria. You can't read it here, but I can just shortly explain it to you. This gray part is just to read in all the necessary data. This green part is to calculate all the material flow costs, and the red part is just to give out our report. And what you can see here, behind every of these tasks is also, even if it's just one line of code, but there is code behind it. So it's kind of effort to set it up compared to this traditional or this conventional way. But if you use it and if you can reuse it again and again, then it's quite helpful, because what you see on the left side, you will get out quantitative data which is directly measured by the model, by the lists, by all the data you've inputted, and on the right-hand side, this type of measurement or this type of evaluation of layer variance is all the time objectively. So if you give it to two persons, you will have two different results out of it. So what we have shown is, so far, or what we can state through our research question, ACABIM or model-based layout planning, or the model-based evaluation of factory layout variance is definitely an approach which we can use to do it more objectively, more quantitatively, and to do it more fast and also more reliable, but it's a lot of effort. You should just use it if you can use it and reuse it in many projects, or you have to evaluate many different layout variants. Then it's quite good to use it if you set it up and you can reuse it again. But if you just do it once, maybe the conventional way is more economic for it. And as a last statement for the outlook, what is really hard for us at the moment is to bring all the information of a production system into BIM models, especially into IFC, because we have no certain entities for it. This is something we are working on, and would be also one cool outlook. We could also use this, or this evaluation is the first step to use afterwards optimization, because then you have like your target definition for your optimization problem, which you can use later on to do something like generative design for factory layout variants. Thank you very much. That's all for me.